What if I told you that nothing around you is truly solid? Not the phone in your hand, not the chair you're sitting on, not even your own body. What if I told you that reality, as you know it, only springs into existence when you look at it? This isn't science fiction. This is the mind-bending truth revealed by quantum physics. Let's start with a simple fact. Everything you see, touch, and feel is made of atoms. We learn in school that atoms are like tiny solar systems, with a nucleus at the center and electrons orbiting around it. But that picture is completely wrong. In reality, an atom is over 99.9% empty space, and those electrons, they don't orbit like planets at all. They exist as a fuzzy cloud of probabilities, a smear of potential locations. They aren't in any single place until something measures them. So the very foundation of our physical world isn't solid or definite. It's statistical. Reality isn't built on bricks. It's built on possibilities. This brings us to the most famous and perhaps the most bizarre experiment in all of science, the double-slit experiment. Imagine firing tiny particles, like electrons, at a screen with two narrow slits in it. When no one is watching which slit the particles go through, something incredible happens. They act like waves, passing through both slits at the same time and creating an interference pattern on the detector screen behind them. It's like a single particle is in two places at once. But here's the crazy part. The moment scientists place a detector to see which slit the electron goes through, the behavior changes instantly. The wave pattern vanishes. The electron stops acting like a wave and behaves like a solid particle, going through one slit or the other, but not both. The very act of observation forces reality to pick a side. It's as if the universe holds its breath until someone looks. This leads us to the concept of quantum superposition. It's the idea that a particle can exist in multiple states or multiple locations simultaneously. The famous thought experiment, Schrodinger's cat, illustrates this perfectly. A cat is in a box with a poison that might be released based on a random quantum event. Until you open the box, the quantum rulebook says the cat is both alive and dead at the same time. It's not that we don't know. It's that the universe hasn't decided. The cat exists in a superposition of states. Schrödinger didn't propose this as a real experiment, but as a warning to show how strange the quantum world truly is when applied to our everyday experience. A particle can be here and there, spinning up and spinning down all at once until it's observed, but the weirdness doesn't stop there. Meet quantum entanglement, a phenomenon Albert Einstein famously called spooky action at a distance. Imagine you have two particles that are linked or entangled. No matter how far apart you separate them, even if they are on opposite sides of the galaxy, they remain connected. If you measure a property of one particle, like its spin, you instantly know the spin of the other. It's as if they are communicating faster than the speed of light, which should be impossible. This spooky connection suggests that our understanding of space and separation might be fundamentally flawed. At the quantum level, distance might just be an illusion. So what does all this mean for our reality? If things are just probabilities until observed and distant particles are instantly connected, what is truly real? Some physicists have taken these ideas to their logical and astonishing conclusion. They propose that our universe might be like a hyper-advanced video game. Reality is only rendered when a conscious observer is there to see it. Think about it. A game doesn't render the details of a world you are not looking at to save processing power. Perhaps the universe does the same. This idea, known as the simulation hypothesis, suggests that consciousness itself might be the player that collapses the wave function and turns quantum fuzziness into the solid world we experience. The universe may not just be a random collection of matter and energy. It might be a system that is, in a way, watching us back. In the end, quantum physics shatters our most basic assumptions about the world. It replaces certainty with probability and solid objects with waves of potential. It doesn't really ask what is real. Instead, it forces us to ask a much deeper question. Who is looking? The answers might change everything we thought we knew. Thanks for watching, and if you want to keep questioning reality with us, make sure to subscribe.